Okay, so I'm going to go ahead and make a quick commit here. It's quite a bit overdue, but we'll go ahead and just make a fairly large commit here for implementing our data seeder. And now let's start to work on the various controller actions that will return data from our database for us, which is really the whole function of our API. And so the first thing I'm going to do is head into startup.cs, and if we scroll down into our configure method, you can see that we have this app.useMVC being called. And we can kind of make a little customization to the way that our routes look here by using a lambda, and we'll just call that routes, and we can say routes.mapRoute, which will allow us to add a particular sort of template to our routes. And so this, we just pass a string, we'll call it default, which is the name of this particular route structure that we'll define, and we'll define it as API and then controller, in curly braces here, action, and then an optional ID. And we can define that with a question mark here. Okay, so that means that we're going to be able to access various controller actions using this URL structure. So in our case, we'll just be running the app on localhost, so it'll be localhost port 5000 /API / the name of the controller, and then / the name of the action, and then some optional ID that we might pass, which will serve as an input to our controller action, sort of controlling the way that it returns some value to us. So if we take a look in our controllers folder, we have this values controller which was created for us. And in fact, we can test this out if we simply run the application. So we'll .NET run, and this is going to fire up the API on localhost port 5000. So as soon as it builds, we'll get that message, and then we can visit localhost port 5000. So bring it over here, and if we take a look at the way this controller is working, we can see that we have attributes responding to the particular type of HTTP request on each of the methods in our values controller. And so we can see for this very simple get method, when we hit /API / values, then we're going to return a new string array with a simple string values, value 1 and value 2. Let's go ahead and try this out. So if we go to API / values, we can see in our browser here, the response that gets returned is this string array. Now I have some special formatting here in Chrome. You can add an extension called JSON Viewer. So I would recommend grabbing this. It's a good extension that you can use to sort of format JSON so that it looks nicer. If we turn it off, just to show you what it may look like if you don't have the extension, you may see something like this. But I do prefer to have the JSON viewer enabled, so it's an extension that I would recommend. Likewise, we have another GET request here where we can see that if we supply an ID value, regardless of what gets passed, we'll return the string value as a response. So if we pass some value here, we simply get value back as a response. Okay, we have some other incomplete methods that were scaffolded out here just to show how we can run HTTP post, put, and delete requests. And these aren't things that you'll be able to actually run from a browser. And so what I would recommend is the software Postman. So I'm going to go ahead and fire that up here. And Postman allows you to actually send post requests, send any type of HTTP request, including post, put, and delete, as you see here, to our API. And so when Postman opens, you can just create a new sort of ad hoc request here, name it like some post request. You can add a description, and you can create collections and add these methods to your collections. We'll go ahead and create a collection called Advantage API. You can see I've created one in the past here. and we'll save this some post request to Advantage API. And basically what you do is you supply the request URL along with the particular HTTP verb that you'd like to send with it. And you can see here, while in the browser we can really only get a GET request by typing the URL into the browser's URL field, we can actually send any type of request here from Postman. So we could post, and although nothing is actually getting returned from our post method that was scaffolded out by the CLI, we should still be able to hit this method. So if our request URL is localhost 5000 /API /values, and we send this post request, we can see the headers, and the response we're getting here is actually unsupported media type. So we didn't supply anything to send up with our post request, but we can see that it's hitting our Kestrel server. So we'll look at composing a legitimate post response when we actually build a post response for our API here very shortly. So Postman will be something that you'll want to have installed, and we'll keep it open here. And as I said, use it once we'd like to test out the post requests and put requests and any other type of requests that we build for our API. So I'll just minimize this for now. And I'm also going to go ahead and close the browser. And we'll stop the server with Control-C. And we'll take a look at our Project Explorer again. And I'm going to go ahead and delete the values controller. You're more than welcome to keep it around for reference, but I'm going to delete it. And we're going to create our first controller here called our customer controller. .cs. Okay, so we're going to start building our customer controller. So the namespace here will be, of course, advantage.api.controllers, and we're going to have a public class customer controller here, which will extend our controller base class. And got to go ahead and put in our curly braces here. Okay, so to use controller, we need to bring in Microsoft ASP NET Core MVC. And we're going to add an attribute to our class here to define the route. So the route for this controller will be API, and then the name of the controller. In this case, customer controller. So now we're going to create a private field for our DB context, which will need to access the entities in our DB context. Now I'm going to create a private field for the DB context, which will need to actually access the data in our database. So I have an instance of our API context, CTX, and then in the constructor for our controller here, public customer controller, we'll go ahead and set the value equal to our API context here. And to use API context, we need to bring in our models namespace. Okay, so let's create a really simple method first, which will just be a basic get method. And I'm going to make all the API methods in our controller here action results. So we'll have public I action result get, and we won't pass any parameters to our get method just yet, but we will add an HTTP get attribute here. Okay, so as I said, we're just keeping things quite simple here for right now. So let's create a var data that will ultimately return. And so what we'll do is we'll get all of our customers from our DB context, and we can say order by, for which we need to bring in link. So we'll do that. So we'll say order by customer ID. This is just to make sure that the data comes back in some controlled fashion. So for now, we'll just sort the results by the primary key on the customer table, which is their ID. And then we're going to return an OK result. In other words, an HTTP 200 response, and we'll provide the response with that. So in this case, just our data. Okay, so the way this is going to work is essentially when we hit our route at API/customer, we should hit our get method here, and we should see the result of our customer objects get returned with an OK response. So let's go ahead and call .NET Run. And so our API is now once again running on port 5000. So if we visit /API/customer, we now get this result with all 20 of our customers. So if we scroll down, we can see that we have all 20 of the randomly generated customers that we have. Keep in mind that all of the company names and the URLs that we have here are randomly generated, and I haven't actually confirmed whether or not they exist, but for all intents and purposes for our application, we should consider all of these fictional. So don't use any of this data for anything but debugging purposes. Okay, so let's head back into our code here, and we'll go ahead and Control-C to shut down the server. And let's go ahead and make another get method here. So HTTP get, and here we'll return an iAction result. And we'll get, except this time we'll have another overload where we actually pass a primary key as an integer, so int ID here. And so the way that this HTTP get will work is that we'll pass an ID, so we'll place ID in curly braces here, and then we can name this route. So we'll call this route get customer, and just need to make sure that we put a closing double quotes here around ID. And so now we have this get method. So we'll say var customer is equal to our context.customers.find, and we'll pass it the ID that we pass our route here. And then we can return an OK response with the customer. So the way this one will work is that, of course, it's a GET request, and we'll hit API/customers/say 5, or whatever the ID is for the customer that we're querying for. So let's go ahead and .NET run again. And so now if we visit, say, customer with ID 2, we should hit this Budget Corporation customer. And indeed, we see that in the response. So pretty simple method there. Go ahead and Control-C to shut down the server once again. Now let's look at how we might create a post request. So we'll create an HTTP post attribute here on a public iAction result post method. And we can use this from body attribute. As you can see from the pop over here, this specifies that a parameter should be bound using the request body. So what we'll have is a request body that maps to the properties on our customer type here. So what we'll say is, first of all, if the customer that we pass this method is null, then we can just simply return a bad request here. We can do that right out of the box with bad request. This allows us to kind of fail in somewhat of a graceful fashion if the post request fails because our customer object is null. Otherwise, we will access our customer context and simply add the customer that is posted to this request. And of course, we need to save changes as well. Once that's complete, we can return a created at route response, and we can call get customer, which is our named route here from our get, and then we need to pass it the ID, which will pass in an anonymous object here. So let's say ID is equal to the customer.id that we just created, and then here's the value of that object, which is customer. So just to see here that the first argument that we pass, the created at route call, is the name of the route. And then we have an object to represent the route values, which in our case will simply be the customer ID that we need to pass to get customer, and then the value of the actual customer object itself. Created at route returns a 201 response, which is the HTTP response used when something has been created successfully. So for this post request method, typically we would have a form, say in our Angular application, for instance, where we would be creating a customer, assigning it its name and email and all that. In this case, we won't even really be using the post request from our Angular application, but I did want to build a single post request out here just to show you how this would kind of work. So let's head over into Postman to test out this post request. So we'll make sure that we'll send up a post request, and then as part of the body here, we can go ahead and post it up as JSON. You could also post it up as form data, where you have these key value pairs with a description, or just raw. We're going to pass it up as JSON just because it's a little bit easier to read here. And we can format the JSON object like this. Let's just go ahead and pass up a primary key ID for the customer. And we'll have one that doesn't exist yet, so we'll say 21. And the customer name, which we'll just say is test post customer. And then here we can make up an email as well. So test@example.com. And then we'll have a state as well, and we'll just use, say, CA for California. Okay, so we'll make sure that we're sending a post request here to our route at API/customer with this in the request body, and let's go ahead and send it up. Oops, and we don't get a response, and that's because we actually need to start our API. So let's go ahead and fire the API back up with .NET Run. And now that that's started, we'll head back into Postman and go ahead and send this request up. And you can see the response that we get back is 201 created. And you can see that the request has been fulfilled and resulted in a new resource being created. So there's the request body that was posted up to our API. So if we head back into our Postgres database and we select star from customers, we can see that we now have a new test post customer in our database. So just a quick kind of side note about how we might create a post method in our API. Since we're basically using the API to simply send GET requests for our dashboard app, we won't spend much more time looking at post request. However, we will look at a put request when we look at how to turn the state of a server on or off, for which we could use a put or a patch request. And so we'll take a look at that here in just a few moments. But this is our basic customer API, where we just have the ability to get all the customers back from our database or get a particular customer back by ID. So I'm going to right click in our controllers directory, create a new file called ordercontroller.cs. And so the namespace will be, once again, advantage.api.controllers. And I'm just going to stop the server for now as well. Okay, so we'll have a few different routes here in our public class order controller. We'll still need to extend the controller base class, of course. So we'll need to also bring in ASP NET Core.mbc. And we'll need to add the attribute route to this class and define it once again as API and the name of the controller. And as before, we'll need access to our context, so we'll go ahead and set that up here. So make our read-only field API context and our constructor. So once again, using dependency injection here to set our context field. And now we need to bring in our models namespace. And we can go ahead and create a few different routes here. So we have 1,000 orders in the system that we've kind of mocked out. Now we could have a request that returns all 1,000 records from the database. But what I'd like to do instead is to set it up so that we do some server-side pagination directly within our API. And so the structure of this will be, for a GET request here, we'll have our API/order/page number/page size. And so what this will do is, looking at all the orders in our system, if we provided a particular page given a certain page size, then we'll return just the results for that page. So in other words, if I would like to show 10 results per page, and view the first page of those results, then I would put 1/10 here. We'll have an HTTP GET attribute, and this time the structure of the route is like page index which we can say is an integer, and then page size also an integer. So now we're going to hit our controller, in this case accessed by our route API/order, and then a page number and page size as integers here. So again, we'll have an iAction result, and this will just be the default get method for this controller. And of course, we're passing the page index and page size. And so eventually we know we're going to return OK with a response here. So let's think first about how we're going to get our data. So we'll have a var data. Again, we'll go into our context, this time into our orders, and we're going to make sure to include the customer explicitly on that order. And so to use include, we need to bring in Entity Framework Core. So we'll bring that in. And so on each order, which I'll just shorten with O here for my Lambda, I want to include that order's customer object. And then afterwards, we'll order everything by descending order. So we'll need to bring in link here. On the order by descending on when the order was actually placed. So that should give us our most recent orders first when this response gets returned. And I'm going to go ahead and break this out onto 2 lines here. Okay, so that's how we get our raw data. Now let's think about how we're going to actually paginate that data. So what I'd like to do here is to create a var page, and we're going to create a new type for this. We're going to call it paginated response. And we're going to make it a generic so that we can pass it an order type in this case. And we're going to pass it the actual data that's returned, first of all. And then we also need to provide the page index and page size requested. So what is this generic paginated response type? Let's go ahead and create it here. We'll create a new file. It's actually going to be relatively straightforward. paginatedresponse.cs. And our namespace is simply advantage.api. And we'll define the method here, public class paginated response. And we'll make it a generic method. To do this, we need to also make sure that we bring in system.collections. And so this is just going to expect us to pass it some type. So let's go ahead and build our constructor here for it so we can set that up. So we'll have paginated response, which will take some enumerable collection of some type, which will be our data. This way we can use this with any of the other types in our system. So orders or servers or customers or anything else that we create in the future. Then we have our I for the page index and length for the page size. And then what I'd like to do is to return some data with our paginated response, as well as the total count of data that we have to page through. So I'm going to create 2 types here just directly within the same class. So we'll go ahead and write some auto properties here for them. So we'll have a total number of objects in our response, and then we'll have our enumerable collection data. If I can spell it here. And of course, to use enumerables, we need to bring in generic collections here. So let's go ahead and do that. And of course, to use enumerables here, we need to bring in generic collections here as well. So my control period's not working. We'll go ahead and say using system.collections.generic. And I see. So I accidentally copied the int down here as well. So we don't need that, obviously. And now we can go ahead and use these types. So we'll say that our paginated response will contain the data. And so if you've ever built anything with pagination before, you may be familiar with this sort of pattern. In link, we can skip a certain number of results, and then we can take a certain number of results from a query. So we'll bring in system.link, and what we'll do is we'll skip the index of the page -1 times the total length of the page, and then we'll take the length of one of our pages, and we'll just call it toList here. So if we think about this on the first page, the way that this would work is, let's say we're looking for the first page where we have 10 results, for instance. So I'll just make a comment here, like first page where we want 10 results. So what we would get here is 1 minus 1, which would be 0, times 10 here for the number of results per page. And so we would essentially have 0 times 10, which would be 0. So we'd skip 0 and then take 10 from our data set, which would give us the first 10 results from our data set. Likewise, let's say that we wanted to get page 2 and return, I don't know, 100 results per page. Then we'd have here 2 minus 1 times the length, which in this case would be 1 times 100 results per page. So we'd end up skipping 100 results and then taking 100 results. So that would be the second page at 100 results per page. So that's kind of how this skip and take is working for us. And we'll set total equal to just the total number of results in the set, which would be data.count. All right, so that's just kind of a simple way to develop a paginated response class that takes any collection of types. Okay, so that's just kind of a simple way to create a paginated response class when working with a collection of sort of any type that you choose. So now let's go ahead and put that to work in our order controller, where our page now is a new paginated response for our collection of orders. We're going to pass it the entire set of data that we get back when we query our database for all of the orders, ordering that set by descending order on the time that the order was placed. And then we pass the page index and page size in used to handle this paginated response from our route values. So now what we can say is the total count is equal to our data.count, and we can use that to determine the total number of pages that we have in our response. And for that, we want to handle the case when we have a sort of remainder here, so we can use math.ceiling and bring in system.math. So we'll be using system, and you can think of math.ceiling as sort of rounding up. It's going to take the number that is equal to or greater than some floating point number that it gets passed. And we may get a sort of decimal or a double in this case, because what we're doing is we're taking the total count of results and dividing by the page size, which of course isn't necessarily going to be a whole number. And so in order to calculate the total number of pages, even if we're requesting 10 results per page and the last page has 1 result on it, then that still creates a page. And so we'll round up when we divide the total count, which is the total count of our data, and divide that by the page size that we're requesting. So then in our response, I'm just going to respond with a new object, and we'll define a page on it, and we'll set that equal to our page that we get back from our paginated response. And we'll just define a page on it here. We'll set that to our paginated response. And then we'll also provide a total pages back in the response as well. That way our response has a little bit of extra data provided back to the user if they'd like to use it about how many more pages are available from the entire data set without necessarily needing to return all of that data in the response. So we'll just return what's needed as requested by the user, but we'll also provide them with some information about how much data is in the system. You might also set something up in this action result here to limit, say, like the max number of requested records, but we'll just keep it simple for now and leave it as is. So we'll return this response with an HTTP status code of 200, and that one should be good to go.